Guys, welcome to Grant Gibbons Tutoring. If you have a glass of water, drink it now. Oh, I sound so corny. All right, so we're doing 12.3 Slope Inference. I'm gonna read the question to you. Number 77 on page 834. All right, it's right here. Beavers and beetles. Sorry that's so zoomed out. It's saying, do beavers benefit beetles? Researchers laid out 23 circular pots. That's our sample size, each 4 meters in diameter. That's just information that doesn't really matter. Okay, it's saying, ecologists think that the new sprouts from stumps are more tender than other cottonwood growths so that beetles prefer them. And they counted the number of stumps from trees cut by beavers and the number of clusters of beetle larvae. So what's going on is beavers are cutting down trees. We have these trees. Oh my gosh, what type of tree is that, bro? Holy crap. Oh my gosh. We have these trees and then the beaver's cutting it down and we just have the stumps left behind, okay? And there's 23 of these plots. This is a stump, this is a stump. There's 23 of these, okay? So the sample size is 23. And they're measuring the number of stumps and the number of beetle larvae, clusters of beetle larvae. And then at the very last sentence, if you read that, if so, more stumps should produce more beetle larvae. Okay, so remember your regression lines, okay? Y equals A plus BX. Our X is gonna be the number of stumps. Why? Because that is what is being changed here. Okay, that is what affecting the Y, which is the number of beetle larvae. Okay, it's saying, this question, if more stumps are made in these plots, then there should be more little beetles in there, inside of the actual stump, eating the stump, cut down by the beavers. Okay, so this is our dependent X, and this is our Y, independent. My bad. This is our independent X, and this is our dependent Y, okay? And this is our formula for our regression line. You should know this. All right, so let's formulate our regression line now using numbers from the question, okay? Because it's asking us, can't quite see it, but it's asking us to construct and interpret a 99% confidence interval. We're in the bottom left here. And then we have all of our numbers right there. Oh my gosh, you can't see it. We're so chopped. All right, you see that right there? Boom. So this is our numbers. These are our numbers right here. Our constant, which is going to be our A, and our stumps, which is going to be our B. Because A is our y-intercept, our constant, and B is our slope. Okay, so y hat equals the constant right here. Not that one, not that one. Oh my gosh, Grant used this. Negative 1.286. And then our B is 11.894. But I think you guys know this, so we're just gonna write these down. All right, negative 1.286 plus 11.894 X. And our X is our number of stumps. And our Y is our predicted, sorry I forgot to say that, but it's predicted number of beetle larvae. Do not forget this. If you don't put this, you're gonna lose like 5 points on the test. Easy way to lose points. Let's get those points because they're easy. All right, now we need to construct and interpret a 99% confidence interval. For what, Grant? Well, for the true slope, the B, the true slope of the regression line for stumps and beetle larvae. Remember, this is our line. Our X is our number of stumps, and our Y is our number of beetle larvae. And this is our constant, our A, and this is our slope, B, from the sample. But we want to estimate the true slope, the population, because these are from the sample, A and BX, but these, A and B, are the true ones. They're the little Greek letters that are kind of weird looking. Okay, so let's start with our conditions. In the question 77A, if you're looking at the textbook, you should have that out, by the way. Pause the video if you don't and get it out. Our conditions are met. Woo! We don't even have to freaking worry about that. All right, but now we have our category. So I'm gonna help you guys to differentiate this. Okay, our category is we want to find, what do you think I'm gonna write? The true slope of the LSRL or regression line predicting beetle larvae from stumps cut by beavers using a T interval, because this is a confidence interval for B, big B. And what is big B? Big B is the true slope. Big A is the true constant. Oof, I'm sorry I did that to y'all, but yes. True, 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 true. When it's a Greek letter, alpha, beta, gamma, alpha, chi, omega, name your sorority, whichever one's your favorite, they are the alphas. They are the true ones, the sororities and the frats. All right, let's lock in. So we're gonna go to calculations now. I'm gonna teach you how to do this by hand because you need to. There is a way to do it on calculator, but the calculator is only if you have the data values already provided. We are given the statistic values. Look here. Ooh. These are all statistics. Data value is this. This is statistics. Okay, calculations. It goes like this. To find your T, no. To find your confidence interval, it's B plus or minus your T critical value times your standard error for B. Oh my gosh, what the frick is going on? I have no idea where to start. Just kidding. Okay, what's B? Remember, B is our slope, and we're already given it. It's 11.894. No way. And then plus or minus, uh-oh. Okay, now this part's gonna confuse me. But you know what? Not really. In this chapter, or section 12.3, DF is n minus 2. Remember, on your blue sheet, you have all of your degrees of freedom. You also have your confidence levels to find your T distribution critical values. We're trying to find our T critical value. Okay, so what's the DF, you ask? Well, what's our N? Remember what I said in the beginning? 23 circular pots, 23. DF equals n minus 2, so DF equals 23. What's our confidence level? 99%. Equals 99%. So let's go back to our blue sheet, okay? I have my degree of freedom. It is 23. Nope, not 23. Guys, I'm so sorry I did the math wrong. It's 21. It's 21, and then our confidence level is 99. So I'm gonna start from 99, go up, 21, 2.831, okay? So that is our T critical value. I'm gonna write it in the parentheses. All right, now what is our standard error? There is a way to calculate this by hand, but it's annoying, okay? Same way there's a way to calculate your B and your A, but it's annoying. So guess what? We already have all the statistics. I want you to point out where you can see SE on the textbook. I'm pointing at it, SE right here. Now, if it's the standard error of B, is that gonna be the constant or the stumps? Well, our constants are A and our stumps are B, so we're gonna take the SE of the B, which is 1.136. Alrighty, 1.136, and that was given from our statistics given to us. Shout out to that. All right, 1.136. Now, let's calculate the confidence interval. So we have 11.894. Oh, I already did it, guys. Don't look, don't look, don't look. 1.136. 15.1, so that's going to be our big side, so I'm going to write that over here since I added. Now I'm going to subtract. It's 2.831, 1.136, And then this is going to be our little side, 8.678 and 15.110. Okay, so that's our confidence interval. Now let's conclude. All right, how confident are we? 99% confident that the interval from 8.678 to 15.110 captures, what did we want to find? The true slope, the beta, all right? That's a sorority letter, the Greek letter. Captures the true slope, beta, of the LSRL regression line predicting beetle larvae from stumps cut by beavers. You might notice that I already wrote this in the category, and you might notice that we had a whole section of stuff just like this before. Oh, actually, wait, I don't even need to write this. See, guys, I got ahead of myself. From stunts cut by beavers. It's confidence intervals. That's all it is. All you're estimating now is the true slope of a regression line given of data points, okay? Nothing special. The hardest part about it is knowing that the Greek letters of A and B are the true versions of constant and slope, and also remembering that your A is your constant, your B is your slope. Your A is your y-intercept, your B is your slope. A is your constant, B is your slope, all right? And that's how you find the true slope using slope inference of statistics given to you.